Hello guys and welcome to this new tutorial here. Today we will gonna build something like that here. So it's how can I say this? It's like a fabric wire growth, something like that. And I will show you how it's done. It's not that complicated. It's pretty simple, and I think we will get started. So let me move that to the side here. Oh, after that we will render it out with Octane. So I got my hands on Octane again. So in the future there will be new tutorials with Redshift and of course Octane too. First of all, we need to place down a geometry container. Let's call this GeoWires. Make it round and black. I did here a file. Let me just open it up. New tutorial, discard. Paste this in. And we are ready to start. First of all, we will need a line, so a guideline that we will use to guide our growth. I will get my hands on a simple curve node here. For example, I will go in the front viewport here, select the show handle tool or just press enter. That will do the same job. And now we can draw here a curve. Let's draw a curve, activate grid snapping for example, and I will do something like that. Right click and stop building curves and show handles. So now you can further adjust the curve here if you want to. That's fully up to you. Let's just drag this a little bit more down here. Something like that. And we are good to go. First of all, this is a 2D curve. So we will get some noise introduced here. Create a simple WOP. So an attribute WOP. Not a cop, a WOP. Attribute WOP. Connect this. And we will just get a simple anti-alias noise connected to the position and add it to the original position here. Make it 3D and increase the amplitude a little bit. And with that we will get just some displacement. Of course, what you can do, you can resample it before and get a little bit more detailed line. But after that we will need a resample. And the resample is important because I will use the subdivision curves and we need the curve U. So the people who don't know what the curve U is, the curve U is simply a value between 0 and 1 along the curve. It's like the UV attribute, so the U, it's just a float value. Let's visualize that here quickly. It's just a float value, so it won't visualize now. Oh, okay, there that goes. It's just a float value from 0 to 1. Let's make this red on the top and black on the bottom. Or black on the top, and this is just a curve U. So it's 0 to 1. Now we will introduce some more divisions here, something like that. That's pretty cool. For example, we can use now the copy the points and a circle. Make the circle a polygon. And just leave it like that and we will get something like this. So our copied geometry is not oriented on the line, and we will do this in the next step. What we will need, there is a new node, it's called copy to curves. It's pretty nice, but we will use our own setup for this. So place down orient along geometry or orient along curve, pipe it in, and you can already see the circle will get aligned to our curve here. That's pretty nice. But we want a little bit of random rotation. So we will get a tangent. The tangent is just the normal directed on the line. And we will get an attribute called up. So let's visualize that here quickly. It's a vector, and this is our up vector here. But I want the orient. It's a criterion, and we can use the criterion. Oh wait, we don't need it. I think we don't need it. Let me have a look. No, we don't need it. We will use that. Okay. Place down a VOP, and we will create now our own criterion with an exporting attribute called rot for rotation. But first of all, go to the circle, place down an attribute wrangle, place down an add. We will delete the geometry, but we will keep the input points, so we will get something like this, the points, but not the geometry. And on the points we will place an integer attribute called id, and this is equals to the point number, so add ptnum. Let's call this add id or set id. And visualize that here, and you can see we'll get a different value on each point. So this is just a simple ID attribute. But the cool thing is, when we copy it, we can connect our polygons to polygon lines with the add node. Disable this, go to polygons, by group, by attribute, and type in ID. With this function we will get the lines, so the points are connected. And I think that's a pretty nice way to do this, and it's also pretty fast. We will go back to our wrangle here, or to our WOP. Let's call this set rot, and dive inside. First of all, create the criterion. We will need an axis. The axis will be our normal, so our tangent. And we need an angle, but an angle in a criterion is a radian product, and the radians go from -1 to 1. So we will convert this. First of all, we need our curve view, because with the curve view we can do a lot of cool stuff. So curve view. This is our curve view here. Let's bind it to the color out and see if it works. Yes, it works. So 0 to 1. Now we want to get the curve view. And with the curve view, I want to create a degree, and I want to convert the degrees to the radians and feed it into the criterion. For that, we will need a degree to radians. That's the node here, and we will pipe that into the angle. The curve view we will use to get it in here, and we will use a multiply to multiply the curve view by our degrees. So the degrees will be an angle, so let's call this mold, maybe let's change it to mold angle. And for the label we can just use, let's call it mold. So I think that's pretty good. So we multiplied that now, but we will need to change that. So the float range here, let's change it from 0 to 1, from 0 to 360. And bind the criterion out. Bind export. This is a 4 float value and call it rot for rotation. Let's dive up and let's see if it works. Yes, it works. But so what I want to do, you can do it like you want, but the multiplier now changed the rotation for each individual. But I don't want that. The cool thing is, oh, we already multiplied it with the curve view. Yeah, okay, sorry guys. So the cool thing is with the curve view, the rotation will affect here not so much, and with the 0 to 1 value it will affect the rotation more. And of course you can already see it. On the top it will rotate more than down on the bottom. Sorry for that guys. So we already did this, but now we want to do another thing. We want to use the curve view with a ramp, with a spline ramp, and bind that out for our p-scale. P-scale. Let's go to our ramp here. And now we can influence our p-scale. That's really nice. We've got our rotation here and our p-scale, so you can change it however you want. Let's just leave it like that. I like that. Select all and go to interpolation B-spline, so it's a little bit more smoother. And now you can change it. For example, like this. So the cool thing is, now we are finished with that, but we need to get some more work done. I want to carve the lines, so we will use a for each primitive. I think the carve node was not multi-threaded in the later version, but now it's multi-threaded. When it's something multi-threaded, you can tell it with the non-compilable sub batch. So for example, I think the poly extrude here is not multi-threaded in a loop, but the carve node is multi-threaded. We got our loop, and with this loop we will now go over each little line or over each primitive. We can show this if we go to our single pass output and scroll here through the single pass, and we will use that to get some randomness. Let's get to the second view, and you can already see what it does, but I want to get a little bit more randomness to get a little bit more organic feeling to that whole growing stuff here. And I think that's pretty easy, because we will use the meta node, and the meta node will give us data for the iteration, for the num iteration, and we can use this detail attribute that will get stored in the detail right up here, so you can see we've got our attributes here in the detail, the iteration path, and this path we can use to influence our growth here. Let's call this how we call this? Just let it on carve. So with our carve we will import now our attribute from the metadata and go to reference, scene data, obj, geowires, our meta attributes, global, and iteration. Of course you can also type it in this little expression, so detail and brackets, and you want to get a iteration attribute. But I usually do it with the reference thing, because I think it's a little bit faster. Now we want to get the randomness, and we can compute the randomness with a rand function. This is our iteration here, so this goes from 0 to 11 or from 0 to 12, because these are 12 lines, and we can use that as a seed. So type in rand, here bracket and here bracket. So we now generate a seed, but I want to fit the seed also. Let's fit it. So fit 0, 1, because the rand function will always give a float value between 0 and 1. And we want to fit this value between, let's get to channels running here. So channel min, channel min, and comma, and channel max. Let's close this, hit apply, and of course we will get a warning because a bad parameter. We've got not the parameter min and max, so we will create them. Go to edit parameter interface, go to float. First of all, let's type in min, then we can copy the parameter here, type in max and label as max, hit apply, hit accept, and the arrow will go away. But our lines disappeared too, but now we can adjust that here. Oops, okay, wait, that's way too high here, so let's clamp that, the range from 0 to 1 on both values here. And now, yes, now it works. So now we make our curve distance random with the influence of the detail attribute. What I will do now is I multiply the whole thing with another channel called, let's call it dist for distance. Let's just copy it. Let's go back into edit parameter interface, copy this, let's type in here the distance, and this will be our distance multiplier. So with the, oh, here's the label. With the minimal value and the maximal value, we will control the randomness in the line. For example, when you get this to 0.9, the randomness is pretty little. But if you want more randomness in your lines, you can dial that down, and you see some lines started right here. So that's pretty cool. Let's give it some randomness, and with the distance you can control the whole growth here. And the cool thing is, when you go over run, it will clamp every line to its end. Something like that. Nice. We created this. For example, you can type in here $T for the time and divide it by let's say 8, and you will get this growth here. You can also make the min and max time dependent, or make it dependent on another value. So we are finished with the growth setup, but now we want to get more wires here introduced, and that's pretty simple. We can use a sphere for that, or place not a circle from edges, place a circle down here. Let's make it a polygon. Let's make it on this plane here. Let's visualize it or place the display flag. We will create a pop network to create particles on the surface here. And what we will do, dive inside, and we'll change here some stuff. So impulse activation, let's do this to the first frame. So $FF equals 1. This will only emit points on the first frame. Let's get here 10 points and disable constant and constant birth rate. So we will get 10 points here on our first frame. Introduce pop wind velocity 1 and amplitude maybe 0.5. Let's dive out and have a look. Yeah, I think that's pretty good. Place down a trail sub, connect as polygons, uncheck the closed rows here because we don't need them, and now we can use the trail length 250, something like that, and we will get different wires here. Of course, now you can play with wind and make an axis force. Oh yes, let's make an axis force. Pop X force. Pipe it into the force. Let's make the radius a little bit bigger and suction speed, pipe that up a little bit. Yeah, that's too much. Maybe 0.5 will do the job. Yeah. And orbit speed, not so much, maybe 0.25. And now you will get some twisting here. So I think that's alright. You can freeze now the trail node and pipe it into the resample, or you can pipe it into the attribute warp to introduce a little bit noise, but yeah, let's just pipe it into the resample here. So we will resample the stuff, but we will get an ID attribute, and we don't need this all attributes, so we can go and place down an attribute, delete, there is it, place it down, and delete everything. Point attributes. Okay, nice. We will resample it, the whole stuff. And I think, oh yeah, we forgot the big loop. So place down, and for each connected piece, place it down here. This will be our output. Place down a null node here, and let's call it out wires. Here, an error because we did not import this right here, and this goes to here. And now we created a big loop that goes for each line and will process the whole thing. And now it will work. I think that's a pretty nice method to create some knitting stuff or whatever you want. Of course, you can now make here a metadata again and randomize the whole thing. But for now, I just want to revert this to default and flip it. And now, of course, you can play here with the values. So it will get spread out in the end, something like that, or it will start off really small and go bigger in the end, something like that. Cool. This is our wire setup, and now we will set up Octane and render a frame. We will need a material network. Let's call it Octane. And we'll need a ROP network, and let's call this out. Let's make it red, but red is also redshift. Oh no, that's bad. Let's make it green. Octane is green, cool. But I don't like this green. Let's make it this green. It doesn't matter. But okay, let's just dive inside here. And we will create a custom Octane render target. First of all, we need here an Octane render custom. Let's make this green for now. And this will get a render target, but we will create our own render target. Dive inside the material network and place down an Octane material builder. But this is not a material, this will be our render setup, our main render setup. Call it Octane and make it red, duplicate it and make this another color and call it matte wires. Whoops. Wires. Dive up. Dive inside of here and okay, we got a curve view, that's good. Let's place down, let's go to the object, to the shelf tool here from Octane. If you don't see the shelf tools, just go here on the plus icon, go to shelves and enable Octane here. Let's get our object parameters running here, and we will import an attribute called curveview, and you also can get an ID and do stuff with that. But I think that's pretty cool now, so Octane supports now the point attributes for now. So we will need a camera. Let's go in the camera and let's get a nice look here. Something like that. Let's make it a wide angle lens. Something like that. And go to the handle tool and we will adjust here our focus point. Another thing we need to do is to go to fur and render object as curves. Now the basic setup is done, and now we will do our render setup. Delete the Octane material and place down a out render target. We will need a thin camera lens, disable autofocus. We will need an environment and a camera environment. So the environment is for lighting and the camera environment is what the camera will see. So the environment will be an environment texture. So you can pipe an HDRI, for example, in here. And we will need a color. an RGB texture image, connect this, go to File, go to HDRI, let's get one of these here. Cool. Then we will need an imager, enable dithering and enable neutral respawns, for example, and we will get a path tracing kernel, and here you can enable adaptive sampling. Cool. Then we will need a camera environment. Just copy this here and place down an RGB texture image, a color, sorry, and make it black. So our background will be black here. Set this to camera environment and set here the backplate. So that's finished. So we can dive up and get here specular material. Yeah, let's get glossy material. Material glossy. That's that for now. Go to our out and we will select here our new render target, so obj, mat or octane, and select this, hit accept, and we are good to go, I think. So let's give it a try. Yes. Oh, we forgot to enable the material. So let's enable the material. And we're good to go. Nice. Now, for example, you can play here with the settings. So 1.4 f-stop to get some depth of field running here. Get something like this. And the cool thing is, with the curve view, we can use now the attribute. So I think it's called it's float vertex attribute. Call it curve view. Reload it. And did this work? I hope so. Curve view. I think it didn't work. Let's go to attributes, curve view. Let's just make this one here f at mask equals at curve view. Let's make a visualizer here, mask. Okay, this will work. Let's get the mask here now. Let's pipe the mask in here. Mask, maybe it was just a typo, but yes, I think that worked now. Or maybe it's the wrong node. Color vertex attribute, mask. Let's just have a look here. Diffuse, reload, tool gradient. Can we mime it? Yes, it works. Nice, cool. So with the tool gradient, with the tool gradient you can now apply color and use the curve view for creating like gradients and get other attributes in. Let's just for now get a camera again in a better position. Just kind of boring, the position. Something like that, and readjust the focus here. And we will get something like this. So that's pretty nice. Of course, you can now adjust here For example, here are some presets: grayscale, infrared, two-tone, white to red, and yes, you can use that tool and other materials. That's fully up to you, but I think that's now the end of the tutorial, and I hope you all stay inside and be aware of the coronavirus. Just Gumroad. I just set it up artistic VDB collection on Gumroad for $5. You can buy it if you want and support me with that. And I hope you liked this tutorial, and I will see you in the next one. So stay healthy, stay safe, and create cool stuff. Bye.